Hello, everyone. My name is Aiden,
I'm Alex.
I'm Joseph.
I'm Alvaro.
and we are the Fearless Ferrets, and this is our enrichment device presentation. So, what is a ferret? The ferret is an animal found in the weasel family. It's most similar to badgers, otters, and minks. Its name comes from the Latin root ferretus, which often translates to little thief. Common behaviors include burrowing, tunneling, and chewing. They often weigh between 1 and 4 pounds and are 16 to 20 inches long. First, it's important to understand the objective, which is to design and manufacture a sustainable, safe, and engaging enrichment device for a ferret. Some constraints that we had were that we were limited on materials, as we could only have a certain amount of plywood and cardboard. We also only had a $30 budget. The device had to be safe for the ferrets, as well as including two tunnels, two treat boxes, and the cage had to fit in our destination. Some considerations that we had were allowing for changeability in parts, as well as ventilation for fresh air, and allow for the ferret to problem solve.
Some existing enrichment ideas that we wanted to look into as a basis for this project involved a lot of tunnels already. Tubes and tunnels were very effective, and a lot of them will also contain play spaces at the ends of these tunnels, so we wanted to include that in our design as well. First off, we thought of doing a box configuration with some tunnels inside the box and then having those tree areas or burrow areas within all one container where you could just put the ferret in. Another design forgoed the box and just had the tubes right out in the open with separate boxes for feeding and just in general having hiding spaces. Main issues that came with these designs was just with the box, where we needed to make it out of enough material and out of a strong enough material. Unfortunately, we didn't have that much. We had a square foot of wood. Another key component is making sure that you can remove the top off the containers and get the ferret out, which it wouldn't allow for. Second design was a lot easier on the material constraints, but it had a lot of design challenges, such as getting the ferret out of a tube.
So for our project, we use about five materials. The first one we use is the quarter-inch thick maple wood, which was supplied by our instructor. We had about a square foot of this, which was not very much for a ferret considering it's about a foot long. That's when we had to pivot and we had to really use that cardboard. We bought a 6 cubic foot box, and it was really important that we did have that extra material to test out. We used two PVC type pipes, which we purchased. These were pretty pricey, but we still managed to fit this in our limit of $30, thankfully. We also used school glue, which was Elmer's branded. We used a fair amount of this. This was our main thing. School glue is very safe for the ferrets to consume, which was very convenient for us. In addition, we did use some wood glue. This wood glue was used on the wood specifically to attach it to the PVC pipes, and it would take months to years of the ferret scratching away. It can't bite through any of that, but it would have to scratch and scratch for months to years to really get to the exposed wood glue, which is still safe in very small quantities. So we made sure to keep it safe as well as durable. Additionally, we laser cut most of our project, as the requirement said. We did have some issues with the cardboard box. We didn't have grooves, so we were trying to stabilize them, and they were not stabilizing because there's nothing to interlock them. So when it came to the gluing process, it was quite difficult. So that's where we had to pivot and make another design. So as you can see, we have our SolidWorks design on the bottom, as well as our final prototype, which we did in class. The main features are that there are two entrances to different components because part of the requirements were that we needed two tubes. So we have the two tunnels. The left side, that is our burrow box, which is made out of cardboard because we needed more materials. The ferret's so big. Top of the burrow box, we add some ventilation with some holes. On the bottom of the burrow box, it's open. There's no panel. So that satisfies our quota of a removable top. And then on the right side, we have our treat box. You can open the top, as you can see there, there's little slits. You can stick your finger in and lift the roof up. And to attach all the pipes, we have our two wooden contraptions. And most importantly, the cages in the Lowell Humane Society where our project is going. They're about 2 feet by 3 feet, and our device fits perfectly with extra room in these cages.
The goal of this test was to make sure that the enrichment device was both functional and safe for a real ferret. First test was the tube clearance test. For this test, we first measured the diameter of each tunnel, and one of the tunnel measured 4.5 inches, and the other one measured 5 inches. These measurements were important because ferrets are long and flexible animals, so we needed to make sure that they could move comfortably through the tunnels. And to simulate this, we used a stuffed animal that had a similar size to an actual ferret. We placed it inside the tubes, and it fit with no issues. We also made sure our hands could fit in without problems into the tubes. And this may sound simple, but it's very important for cleaning purposes and maintenance. For the second test, we focused on the weight of the structure and how much weight it could support. Combined, the prototype weighed about 1.6 kilograms or 3.5 pounds. This makes the device easy to lift, transfer, or reposition inside an enclosure. Next, we simulated the weight of a real ferret. On average, ferrets weighed around 5 pounds. So we applied that weight inside the device to see if anything would collapse or detach. The prototype stayed perfectly stable. Nothing came loose, and the structure didn't deform. This confirmed that the design can safely support the weight of a ferret, which is a key requirement for any enrichment device. As a group, we were very happy with the final product, but getting to this point wasn't easy. In summary, our reflections showed that with better materials and improved early communication, the next version of this device could be even more durable and efficient. For future improvements, the biggest change we will make is using more durable materials. We face limitation in strength and long-term durability. We would also try to find the cheaper alternative to PVC so that the device could be reproduced more easily and at a lower cost.